Hi, my name is Thomas Paul. I work for Scion Research. I'm a forest ecologist, and I will talk about parts of our Winning Against Wildings program, looking at remote sensing and detecting wilding conifers in large landscapes. All right, mapping trees across large landscapes is a specific challenge, especially if at the same time the capture of details about the detected trees is required. Today, I want to talk about a number of projects that Scion conducted in collaboration with the National Wilding Conifer Control Program run by MPI and the government, which all lead to developing remote sensing approaches to detect wilding conifers across large landscapes. But first, a bit of background. Why do we actually have wilding conifers in New Zealand? And I will use the mountainland revegetation research as an example. In the 1960s to 70s, several hundred different plant species were planted at altitudes from 800 to 1500 meters because New Zealand feared that their mountainlands are eroding at an incredible speed and something needed to be done. However, many species, including most natives, failed completely when they were planted in those areas, but not so exotic pines. With that, the Forest Service and the high country land managers planted most successful species like lodgepole pine, Scots pine, ponderosa pines in those mountain lands as woodlots, erosion protection and shelter belts. But those wilding conifer, but those pines are now our most prolific wilding conifers. In 2014, this was realized that we're getting an increasing problem of wilding conifers in our high country, and the government developed the New Zealand Wilding Conifer Strategy. And this was done because we wanted to eradicate or contain existing infestations and prevent further spread, as historic data showed that the extent of wildings will exponentially grow over time, as this one graph on the right-hand side shows. At the same time, researchers started to develop a research program to support that strategy and providing research into impacts, legacies, detection, which I talk about today, control and prevention measures to stop this. In the detection space, the vision was to be able to map and support the management of infestations at various scales in the landscape. As it is essential to be successful that you have to know where and at what stage wilding conifer infestations are, and this becomes instrumental to manage and control wilding conifers. So with this in mind, we look to develop a scalable approach from landscape to individual trees to measure and map them in New Zealand from the landscape down to the individual. To be able to do that on the landscape is important for management operations to understand how big the problem actually is. The area of incursions, we wanted to understand how quickly those infestations actually spread and to be able to detect them early enough to be efficient in our management. On the individual level, we aim to record metrics of those trees that help us to optimize our management and our control operations. With that kind of approach identified, we realized that probably remotely sensed imagery from a number of platforms are the better candidates. So from manned aircraft or from UAVs, capturing high resolution and spectral composition imagery would serve probably that purpose. However, there are a few challenges if you try to do something like that. For example, the capture of that kind of data need to be efficient and economic, especially if you deal with 2 million hectares around in the high country, which this map shows in green. Furthermore, there's a high diversity of landscapes and vegetation cover types that you have to deal with which makes detection algorithms complex or difficult to deal with. Also, the detection of small trees or outliers is a critical step, and that is shown in the lower photograph below, where I circled small trees that are already there, which are already hard to see, even if you just look over the landscape. Those kind of situations can really develop fast from those scattered outliers into dense stands, where the effect of the infestations are detrimental and often irreversible. So really, control needs to happen before invasions can spread further, so the trees growing too big and start coning already. So as a first task, we worked on a paper to really identify the detectable size with imagery that is readily available and can be captured over large areas. And we compared a range of platforms, as said, UAVs and manned aircraft, and various sensors, including LiDAR and spectral. The study identified that we are really comfortable and we have a good accuracy to detect wilding conifers that are of a height of 1 meter or above. That's actually a critical height in terms of development of a tree, as in the high country we found that one of our most sporadic spreaders, lodgepole pine, would start coning if it reaches that size or over, and we wanted to be able to detect infestations before this occurs. So really most practical for mapping was the use of multispectral imagery captured by manned aircraft across large areas, and then using that with models or algorithms that often work on supervised pixel-based classification. While this gave us confidence in the mapping side, we wanted to test the usability of exactly those combinations to derive certain metrics from those remote sensing maps to look at how can they actually support the management of wilding infestations. And we used the basis of that as a paper that has recently come out that we worked on to look at how complex and how the costs are actually driven when we deal with wilding infestations and want to control them. So there were really three metrics that stood out, and they came out in that flowchart that you see on the right-hand side, and mainly in the green boxes. And that's identifying really and understand the real area that needs to be controlled. So where are those trees and how are they looking? The density and the tree size that comes with it. And that's critical for applying the right control methods that can reach from boom spraying to individual cuttings. And the big question afterwards was really, is there a follow-up required, or are we successful with just one hit in terms of control? So with this in mind again, we embarked on the acquisition of two imagery types for two areas in Molesworth. Molesworth sits in the northern part of the South Island, is currently probably the biggest management unit that the Wilding Conifer Control Program is managing at the moment, and conduct large control operations. As said, two approaches were used, imagery was captured, RGB-based or multispectral-based, and then we applied two different approaches linked to the imagery that we captured. One was a geo-artificial intelligence tool, convolutional neural network, and we used the RGB for that with a very fine resolution of 8 centimeters. We conducted another approach, which was a simple feature collection and extraction system or algorithm, which is kind of a semi-automated model. And we used the multispectral imagery, which had a lower resolution of 25 centimeters. So while the study is still ongoing, I will just present the brief results utilizing the multispectral imagery because that gave us really good results. So we really captured the whole area of 176 square kilometers using the multispectral imagery. We ran our semi-automated classification approach, and what you can see on the map in dark red are actually the infestations in that landscape. Now we're getting a good idea about how far the infestations have spread in that area and where they're located, here especially around the homestead and close to woodlots and shelter belts, which is shown in red. In total, nearly 2.5 million square meters of this area is covered in live wildings. In other terms, you could say 242 hectares out of the 176 kilometers has really canopy cover of wilding conifers. So that's roughly 1.3% of the total area surveyed, and that indicates a little bit how complicated it can become when you try to operationally control it, because you need really to know where they are and at what density to be able to do and conduct targeted control. So it's like a needle in a haystack, especially if we look at the size distribution that I show in this slide. So this is really a histogram about canopy sizes of individual or clustered wilding conifers across Tarndale. And it shows that when we calculated canopy area, that a lot of really small trees are in that landscape. Small defined here as a canopy cover of 3 square meters of canopy cover individual trees. And those really make the bulk of the scattered trees. On the other side, we have areas where trees are really densely clustered with over 20 square meters in area, which is shown on the right-hand side of that graph. So this is important because that already highlights the need for a range of control approaches, which mainly work on density and size classes. So what you can do with that kind of captured and modeled data is then use that demographic data that we're getting out of it and the density to allow the calculation of hotspots. So really dense areas with larger trees that allow, for example, boom spraying, which is one of our most cost-efficient control operations that we have available. And those are shown in that map as a more detailed one in the pink areas, while the blue ones are really the scattered individual tree crowns of single trees, which probably will require work on the ground like cutting or spraying individual trees. Another important aspect of that is, and it shows in the map in the red circles, is that there have been already control operations in that area, which are the dark red areas, which indicates dead trees. But it also shows that a lot of individual single trees are still in there that haven't been really affected by these control operations, showing that there is a follow-up required in those areas if you want to eradicate wilding conifers. So really the outcomes, how far we got, is that we're now getting to a stage, I think, where the wilding conifer management and the operational control operations will start using large-scale remote sensing and the associated mapping approaches to map wilding infestations across the wide landscapes and use the data, the detailed data that comes out of it for control operations and for planning to get the efficiency gains that they really need. Time series will allow the monitoring of control operations if we do that on a regular basis, and we can identify the efficiency. as well as new models based on remote sensing technology, will contribute to the better prediction and invasion modeling. And I will quickly like to thank all the science team that has been